Tired of juggling keys and wallets just to move a stablecoin? Here's how to create, fund, and send USDC entirely from your backend using Circle Developer-Controlled Wallets. Hi, I'm Elton, and I work on the developer relations team at Circle. Welcome back to Stablecoin 101, a series by Circle where we break down the foundations of stablecoins and how they are powering the new internet financial system. In our last video, we introduced Circle Wallets, explained their core functions, and looked at the 3 wallet models you can build with: developer-controlled, user-controlled, and modular. If you haven't checked that video out, you can find a link in the description below. In this video, we're going hands-on with developer-controlled wallets and walking through how to set up your project, register your entity secret, create and fund wallets, and send a USDC transaction on Ethereum Sepolia. So whether you're building a payout platform, treasury automation, or customizing finance flows, this is the foundation you need to program USDC at scale with full backend control and multi-party computation signing handled securely by Circle. Let's start by setting up a simple project so that we can interact with Circle Developer-Controlled Wallets from our backend. First, create a folder. I'll call mine Circle DCW demo, but feel free to use any name you like. Then, initialize a new Node.js project. Now, we install the packages we need. This includes the Circle Developer-Controlled Wallet SDK, VM for blockchain RPC calls, .env for managing environment variables. Once that's done, open the folder in your editor. I'm using Visual Studio Code. Next, open package.json and change the type from common.js to module. This allows us to use modern import statements in our scripts. Now we're ready to connect to Circle Developer-Controlled Wallets. We'll start by generating an API key and setting up your entity secret, which acts like your secure signing credential. To generate your API key, head over to console.circle.com and log in. In the sidebar, go to API and client keys and click Generate Key. Once created, copy the full API key. In the root of your project, create a .env file and paste in your API key like this. We'll come back to this file later to add more environment variables. Next, we'll generate an entity secret. The entity secret is a cryptographic key that you use to authenticate your API requests. It stays with you just like your own private signing credential. Let's create a script and call it generatesecret.ts. Then run it using npx tsx. This will output a brand new entity secret. Copy it and add it to your .env file. Last but not least, we'll register the entity secret with Circle and download a recovery file. This file is your only backup of the secret. Circle doesn't store it, and you won't be able to recover or regenerate it later. So make sure you store it somewhere safe. Create a new script and call it registersecret.ts. Then run the script. If everything worked, you'll see a recovery file saved in your project directory. Hold onto it in a secure place. At this point, you have set up your environment file, generated your entity secret, registered it with Circle, and saved the recovery file. Now, we're ready to move on to initialize the SDK to start working with wallets. With your API key and entity secret set up, we're ready to initialize the SDK and start working with wallets. First, create a new script file and call it walletdemo.ts. In this file, we import the SDK and initialize the developer-controlled wallets client using the credentials from your .env file. Then run it. If you see SDK initialized, you're all set and ready to move on to the next step. Now, let's create a wallet set. You can think of it as a group of wallets that share the same cryptographic key. This lets them use the same wallet address across multiple EVM chains, which makes cross-chain development much easier. Let's add this to walletdemo.ts. Now, let's create 2 smart contract wallets on the Ethereum Sepolia testnet, both fully managed from your backend. If you aren't yet familiar with Sepolia, it's a test environment on the Ethereum blockchain, a sandbox for developers. You can use it to create and interact with wallets just like you would on the mainnet without spending real ETH. Add this to the same script and run the script once more. You'll now have Wallet A and Wallet B, smart contract wallets that are fully programmable and entirely controlled from your backend. Before we test out transactions, you need to fund Wallet A with some Sepolia ETH and USDC. Go back to the Circle Developer console and in the left-hand sidebar, open the faucet. In the Wallet ID field, paste the ID for Wallet A that we logged in the terminal. Then select Sepolia ETH and USDC. Then click Send Tokens. After a few seconds, you'll see testnet ETH and USDC deposited into Wallet A. Now, to confirm the balance, there are a few ways to check that the funds arrive. For the first option, you can use the Circle console. Go to Wallets, Click on Wallet A and you should see 0.01 ETH and 20 USDC, or Etherscan. Head to Sepolia etherscan.io and paste in the Wallet A address. You'll see both ETH and USDC balances and the most recent transfer listed under token transfers. Now that we've got a funded wallet, let's send 1 USDC from Wallet A to Wallet B using the SDK. From the terminal output in the first script you generated, grab the Wallet A ID and Wallet B address and add them into your .env file. We'll come back to add the USDC token ID in just a moment, but first, we need to create a transfer file. Create a new file called transfer.ts. This script will initialize the SDK, fetch Wallet A's token balances, and help you pull the USDC token ID. Then run the script. This will print out all the token balances in Wallet A, including the token ID for USDC. Copy the token ID shown for USDC and paste it into your .env file like this. Now that we have added the token ID to our .env file, let's complete the transfer logic in transfer.ts. This will submit a transaction from Wallet A to Wallet B, poll the transaction status until it's confirmed, and print the final on-chain hash so that you can verify it on Etherscan. Update transfer.ts with the following code. Run the script once more. You'll see a live status log in a terminal, and once the transfer is confirmed, it will print the on-chain transaction hash. Copy the transaction hash and head over to sepolia.etherscan.io, paste the hash in the search bar, and you'll see a completed ERC20 transfer event showing 1 USDC sent from Wallet A to Wallet B, executed fully from your backend using Circle Developer-Controlled Wallets SDK. And there it is, a complete USDC transfer live on Ethereum Sepolia. If you've made it this far, great job. Let's quickly recap what we've covered. We set up the project and installed the SDK, generated and registered your entity's secret, created a wallet set and spun up 2 smart contract wallets, funded Wallet A with testnet ETH and USDC using the Circle faucet, and finally, sent 1 USDC from Wallet A to Wallet B using Circle's SDK with secure signing handled behind the scenes by MPC. So whether you're building payouts, treasury automation, or financial infrastructure for your platform, developer-controlled wallets give you full control and a production-ready foundation to build with USDC at scale. Ready to go deeper? Check out the rest of the Stablecoin 101 series to learn more about how stablecoins like USDC are shaping the future of digital finance. See you in the next video.